Okay, for today's notes, we are going to talk about literal equations some more. We're on page 313 in the notebook. So literal equations, what does that mean, literal equations? It's actually its own special version of solving equations. And it means equations with multiple variables. It's not just going to be one variable you're going to get a number answer for. It's going to be multiple variables, so you're going to end up with an answer that isn't that nice looking. And we kind of did some problems with like this yesterday, where we started with a typical solution, typical equation that we've been solving all along. So if you look at this equation here, I want to get x by itself. I'm going to add 5 to both sides. This becomes 0. I get 2x equals 13 plus 5 is 18. 2 is being multiplied by x, so I'm going to divide both sides by x to turn this into a 1, and I get x is equal to 9. This is very similar to the right, except it doesn't have a 2 and a 5. It has an A and a B and a C. It doesn't have 13, it has C. But it's the same process. I'm solving for x. So I've got to get rid of this minus b by adding b to both sides. Becomes 0. I get ax equals b plus c or c plus b. You can write it either way since addition is commutative. Then I've got a times x. I want to get rid of this multiplication. I divide by a, and this becomes 1, and dividing the other side means fraction bar over a, and end up with x equals b plus c over a. The answers look different, but notice the process was exactly the same. It's just that you didn't have any numbers on the right to simplify anything. So identify the similarities and differences between the two equations. Well, what's similar is that it's the same steps, right? You're undoing. To undo operations where the variable is on the same side as the variable, right? So it's similar, right? Same steps to undo the operations where the variable is. You want to get the variable by itself. What's different? Well, the big difference is more than one variable. So you have to really pay attention to what they're asking you to solve for, because there might be more than one variable. You have to make sure you're solving for the one they're asking about, but that's the big difference. And the answer isn't a number, right? You don't just get x equals 4, you get x equals b plus c over d, right? So let's go through some of these together. And a lot of times we do this for formulas. A equals LW is the area formula for a rectangle. Area equals length times width. And like I said, you have to pay attention. What are they asking you to solve for? They want you to solve for W. They could have asked you to solve for L. It's already solved for A. So let's look. To solve for W, I've got to get rid of the L. Well, what's going on there? It's being multiplied. So I have to divide both sides by the L. So I'm going to divide this side by L, and I get A over L. And this becomes a 1. L over L is 1 equals W. So I solved for W. I did what they asked me to do. I'm going to let you do number 2, and I'm going to let you do number 3 because they're very similar. Just make sure you're paying attention to what are they asking you to solve for. So let's look at number 4, because 4 is a little different because it's got more stuff on the right side. It's got 3 variables being multiplied. But let's see what it's asking for. Solve for t. There's t. I have p and r being multiplied by t. So I can divide one at a time, but I could divide both of them at the same time because p over r divided by p over r, whatever those numbers would happen to be, is always going to give me 1. The same thing over the same thing is always 1. So I do the same thing to both sides. I get I over p r equals t. Okay, so number 5 you're going to do because it's very similar to the one we just did. Let's look at number 6. Number 6 is extra confusing because it has an exponent, right? But we're solving for r. We have to get r alone, okay? Just r. When we're done, we have to have it be equal to r. So the first thing I'm going to do is look and say it's being multiplied by pi. So I'm going to divide by pi. And then I get the pi over pi to become 1, so a over pi equals r squared. Well, squared, how do you undo squaring? And this is really, really important. right? Square root this undoes squaring, right? So what I have to do here is, because this is r squared, I am going to take the square root of both sides. And just to kind of give you some notes here, if I take the square root of x squared, that's x, okay? So that's why you had to take the square root of r squared. And when you do that, you end up, for your answer to be, because you did on the left as well, the square root of a over pi equals r, because this is equal to r. So this is one of the trickier parts of solving literal equations, is undoing the exponent. And for squaring, you just have to take the square root. It sounds, complicated, but it really isn't. And if you look at your answer in the end, you just have the square root of a over pi equal to r. So I am going to let you do number 7 by yourself, because that one's similar to ones we've done in the past. Number 8, though, we'll do together. We're solving for m. Here's m. What's happening to m? It's being divided by v. What's the opposite of dividing? Multiplying. So you need to multiply both sides by v. When you do that, this becomes 1 and you make it go away, and you end up with v times d equals m. And you got m by itself. So again, solving for the variable is the thing you have to really pay attention to in these, because there's usually more than one variable. Let's go to the next page. They give you some tips. Think backwards, PEMDAS. That means you're finding your addition to undo, you're finding your multiplication. And now that we have exponents, so like you undo, oops, sorry, let me erase all that, that's crazy. You're undoing addition, right? Then you're gonna undo multiplication, and I mean subtraction and addition and multiplication and division. And then you're gonna undo exponents. That's kind of a new thing for us to undo exponents, but we'll have probably more examples for that in this. So remove fractions by multiplying by the reciprocal. So you guys should be pretty familiar with that, right? We've done that with regular equations. And then the last step is usually divide by whatever is next to your variable to get that into become a 1. So those are some hints. Let's keep going with this. We've got a fractions. We need to, on number 9, solve for h. There's h. How do I get rid of this fraction? I multiply by the reciprocal, which is just 2 over 1, which is really just 2, right? I can write 2 over 1, but it's really just 2. So I end up with 2a equals, this whole thing becomes 1, bh. Again, I'm trying to get h alone. B is being multiplied by h. I'm going to divide by b on both sides. This becomes a 1, and I get 2a over b equals h. And that's solving for h for number 9. I'm going to let you do number 10. Let's go to number 11. I'm solving for m. Here's m. I have an exponent, but it's not tied to the m. So I'm not going to have to really worry about it as much as if it was m squared. But let's see. I've got division and I've got multiplication. I'm going to get rid of the division first. I could probably get rid of all of it at once, but let's just do divide by 2 first. Let's get rid of that. So to do that, I multiply by 2. I'm going to do that on both sides. This becomes a 1. And over here, I end up with 2k equals mv squared. I'm trying to get m alone. It's being multiplied by v squared. So if I divide both sides by v squared, this becomes a 1. No matter what it is, anything over itself is always 1. I'm going to divide this side by v squared. And when I do that, I get m by itself. I get 2k over v squared equals m. So for this one, because I had to solve for m and it wasn't tied to the exponent, I didn't have to worry about undoing squaring. Okay, this next one, solve for b. So where's b? It's in the numerator here. So what do I have to do? Normally I would say get rid of the adding first, but because everything's being multiplied by d, we're thinking about it like it's this whole thing being divided, so we have to multiply both sides by d. This becomes 1, and I end up with d times a equals, and I don't need the parentheses anymore, b plus c. I'm trying to get b alone, so I have to get rid of this plus c to make it 0. I'm subtracting c from both sides. over here, this is confusing, but it's really just d times a like you had originally, and you're subtracting c, and this all equals b because the plus c and minus c went away. And I know this doesn't look nice and it seems weird, but that's what it is. There's nothing more you can do because you don't know the numbers. You just had to go through the steps to solve, but you had to leave all the variables there. Okay, let's look at number 13. Number 13 wants me to solve for w. Here's w. So I need to get rid of the multiply by 2 with the w, but also the plus 2l. So the plus 2l is what I need to get rid of first, get rid of addition before multiplication. I'm going to subtract 2l from both sides, and this becomes 0 over here, and I end up with p minus 2l equals, and I have 2w on the right. To solve for w now, I need to get rid of this 2. It's being multiplied, so I'm going to divide by 2 and make that a 1. So I got to use my fraction bar and divide the whole thing by 2. And when I'm done, I end up with p minus 2l over 2 equals w. It doesn't seem like it's a solution, but it is because you needed to solve for w and you solve for w. I'm going to let you do number 14 because it's super similar and you can use it to number 13 as an example to help you figure out number 14. Number 15 also you can do on your own. Number 16 we'll do together. So let's look at number 16. We're solving for t. Here's t. It's kind of similar to the other ones we just did. T's being multiplied by some stuff, but then it's also got p being added. So we're going to get rid of that adding part first, and we're going to subtract p to make that a 0. So you end up with a minus p equals capital P R T. Because these are all multiplications, I need to undo them by dividing. I can actually undo them at the same time because p times r over p times r is going to be 1 no matter what those numbers are. I got to do the same thing to both sides. So PR on the bottom here. And that's my answer because A minus P over PR equals T. And I got T alone. That was my goal. Okay, number 17, solve for F. Here's F. Normally we'd say, oh, your parentheses, you need to distribute. But because we're solving for F and we have variables, we're not going to get a simple answer. And it would be easier to just get rid of this 5/9 by multiplying by the reciprocal when I do that, right? On both sides, this becomes 45 over 45, which is 1. And then on the left side, I end up with 9 times c over 5 equals f minus 32. I can lose the parentheses because now I got rid of the 5 over 9. You could have distributed, it just would have made the problem more complicated because you would have had to multiply 5/9 times negative 32, which would have been complicated. So this makes it a little easier. This step gets rid of it, and then you could just work with the f minus 32. You're trying to get f alone, 32 is being subtracted. You're just going to add 32 because you want to make this a 0. So over on the left, you have 9c over 5 plus 32 equals f. So it seems kind of crazy, but that's what it is. Then, next one. This one is really the most complicated one you'll ever see. It is actually the area formula for a trapezoid. If you didn't have that memorized. And we want to solve for B1. So we've got to get rid of all this stuff in front of the parentheses and then get the B1 plus B2 by itself at the end to solve. So getting back to our old fraction friend, multiply by the reciprocal, 2 over 1. This is really just like multiplying by 2. So when I simplify on the left, it's just 2a equals. This becomes 1, and I have h times b1 plus b2. I want to get rid of the h out in front of the parentheses, so I'm just going to divide it by h because it's being multiplied by h. And this becomes 1, right? Remember, I get rid of it by dividing it by h. If I subtracted it, I can't really do that because then it's connected to this b1 plus b2 in parentheses. But I can divide it, and it becomes 1. So now I've got 2a over h equals b1 plus b2. We're trying to get b1 by itself, so we just need to subtract b2 to make that a 0. And then when I'm done, I end up with 2a over h minus b2 equals b1, which seems like a mess, but my goal was to get b1 by itself. I got b1 by itself, and I took all the steps that I needed to take to move the variables to the other side by undoing everything. So that's your notes for littler equations.